So what I'm going to do in this video is show how to connect a ultrasonic range sensor, particularly the type SRF04, to a Arduino. So here we can see the cables connected from the ultrasonic range sensor into two pins of the Arduino. So I'll just tell you how this works. So the back of the ultrasonic range sensor has got power, ground, it's got a echo output and a trigger input. So how it works is looking at this timing diagram here. So the microcontroller, or the Arduino, needs to give it a short trigger, 10 microseconds minimum, as you can see in this top one. Ignore the graph in the middle, that's what happens through the ultrasonic sensors and transmitters that are on the actual device itself. And what happens is, after a short period of time, a pulse of varying length comes out of the sensor and from the echo output of the sensor. So it's a pulse length, it says here in the diagram, between 100 microseconds up to 18 milliseconds. So what happens, the length of that pulse, if you time it in microseconds and then divide that number by 59, I think it is, it then equates to a distance in centimetres. Little bit of a bizarre value, but that's what it says on the data sheet. So what I've got here is a program which is written, and I've got the Arduino connected to the ultrasonic sensor. I've used pin 7 for the trigger and pin 8 for the echo. So the trigger is coming from the Arduino, it triggers the ultrasonic sensor, sets the sensing, and then pin 8 is a pulse length which comes back. Now, just in the setup, you'll see that the pin modes are set to be an output from the Arduino and an input back into the Arduino. Serial begin is just a way of having serial information sent back to the computer, so it can send things like the distance, and it will send the distance in centimetres. Now, just below we've got the main loop of the program. I've got a variable named duration. And then the first thing it does is it sets the trigger pin. First it sets it low, and then there's a short delay, 2 microseconds, and then it writes it high, and then a short delay of 5 microseconds, and then it sets it low again. So that's a trigger set for 5 microseconds. And then in the Arduino, it's quite nice, there is a command called pulse in, and that will time the pulse in microseconds. So what it does is it will return into duration how many microseconds the length of that pulse is on pin 8, going from low to high and then back to low again. Now, as in the data sheet, it says, well, that duration, if you divide it by, I said 59, it's actually 58 or thereabouts, it will turn that into centimetres. And then serial.println, it will print the value in centimetres, and it will send that to the communication port. In this case, we're going to use a computer, so we'll see the value. And the delay 100, that's in milliseconds, so there'll be a short delay in between values. So the Arduino is connected through a USB port to the computer. So I'm just going to program it, so I'll just move my cursor. First of all, we might need to make sure that we've got the correct COM port set. This one has been set, so there's port 45, and it is an Arduino Uno. Fantastic, so I'll just program that. So it's uploading it. We get the bar on the right-hand side going through, and then when that's completed, it says uploading, and then when it's completed, it says done uploading. Great, so that should be all on the Arduino Uno. So now it'll be sending trigger pulses to the ultrasonic sensor. So one of these is a transmitter, transmits a beam ultrasonic sound, we can't hear it. It then reflects off an object, and then the sound is reflected back to the receiver, and the time it takes for the sound to be transmitted and then received is converted by the small microcontroller in this ultrasonic sensor, and then sent as a pulse length back into the Arduino. So what I'm going to do now is go onto the serial monitor and have a look at the information. So we should have some numbers. So we've got some numbers scrolling through there. A little bit of noise there. Sometimes you get a high number, but those numbers are relative to how far my hand is away from that ultrasonic sensor. So as I move my hand closer to the sensor and further away, you'll be able to see a little bit of noise there, which you could filter out later, but you should be able to see the numbers changing. Now what you can also do with the Arduino environment is turn this into a graph. So this is quite a nice thing that it has. So serial plotter, as long as it's just a number with a print ln, so it's got an enter return character at the end of it, it will turn that into a graph. So what we should see is a graph forming, and as I move my hand to closer and further away, let me just move back like that. You can see a little bit of noise sometimes, but as I move my hand around, you'll be able to see the values changing. There we go. So as I move my hand further away, goes up, and then as it gets closer, the value should go down like that. So we have something a bit like a theremin really, where up and down we can see these values. So I'll just zoom in on that a little bit. Should redraw. There we go. It starts to scroll across the screen as it redraws, just like that.